Hello. Today we're going to be factoring completely. We're going to do lesson 8.1. Let's get started. We're going to do some review and use these concepts in the review for an expansion. So get your whiteboards out. On your marks, get set, go. Factor all three of these and keep them on your board. We're going to do them together in a moment. I'm going to give you a hint on letter A, the greatest common factor. Pause this video and go ahead and get started. Welcome back. Keep those answers there. We're going to do letter A here. We're going to take out the letter 3. The number 3 actually, and we're going to take out an X in all of them also. When we do that, we will have left 3 times what gives us the 24 xy squared, and that will be 8y squared. We have the 54x squared next, and 3x times what gives us the 54x squared? And that will be 18, negative 18x. What times 3x gives us the 18x cubed y, and that will be 6 x squared y, and we are finished. This one over here is a difference of squares. You should be recognizing those by now. This is a perfect square, so x and x go there, and a perfect square of 100 goes here. A perfect square of 100 is 10 is its perfect square root, and we have a plus and a minus, and it makes a plus and minus there. This one is another special one, and it's a perfect square trinomial, and if you didn't know that you could use your box method, you would have got x and x, a minus and a minus, and a 7 and a 7, but we cannot write it that way. We need to write it x minus 7 squared. We're going to use these concepts today, and we're going to factor multiple things, actually multiple times. So get out that worksheet. Take really good notes. I've given you some steps at the top up here. The very first thing you should always look for is the greatest common factor. Then the second thing is you should look for a difference of squares or a perfect square trinomial. And if you can't find that, you're going to do a box method to see if you can break it down, and then you're going to make sure you can't break it down even further. Let's get started. What can I take out of 27 and 75? I can take out a 3. When I take out a 3, what's left is 9 u to the 4th minus 25 v to the 4th. And then now you need to look. You're not finished. In the past, once you did the greatest common factor, you were finished. But this is a perfect square trinomial. Don't let that 4th degree trick you. We will have some binomials there, but don't forget to bring down your 3. We put it in the front and leave it there, because this thing that I have underlined in yellow is going to be split into 3 u to the 2nd and 5 v to the 2nd, but we'll have a plus and a minus. Can this be broken down? Now that's the one that might be able to be broken down. You need to look. Is that a difference of squares? Because you know before you've been studying this that sums do not factor, but differences might. And this is not a perfect square, so we're done. Let's do number 2. Can I take something out? The greatest common factor. Can I take something out? Yes, I can take out a 4. I had someone notice previous that this is a perfect square trinomial, but be careful. You need to factor first and then see if it's not a perfect square trinomial. Someone told me that this was a difference of squares, but first take out your greatest common factor because it will make your life simpler later. This, after I take out the 4, is 25 x to the 4th and 4 y to the 4th. And yes, this still is a difference of squares. So that will factor into 2 more binomials, but don't forget your 4 to bring it down. This will be 5x squared minus 2y squared, and then the same thing except a plus instead. Check out your difference and make sure it's not a perfect square trinomial. Since 5 and 2 are not perfect squares, we're done. Let's do some more examples. Feel free to stop the video at this time and try these on your own. Make sure you come back to check because there's some pieces that you have not seen before. Welcome back. Let's try this one. Can I take something out of all of these? Yes, I can take out 4. When I take out a 4, I'm left with 11x squared minus 37xy and plus 12y squared. This is not a difference of squares this time, but you can do something with it. This is our box method. We're going to turn this into 2 more binomials, but don't forget to keep your 4. So we ask ourselves, with the 11x squared, what can I break that down into? And that'll be 11x and x. What about the 12? 12 can be 6 and 2, 3 and 4, or 12 and 1. We want this center to be 37. Remember, we do the checking with the diagonals. So I'm going to check over here to find a number that gets me 11 times something that gets me close to 37. And I'm noticing this 3. 3 and 4 have to go together. So if I do a 3y for that y squared that's there and a 4y, let's see what happens. Let's see. This is going to become 33 this direction. 33xy. And this is going to become 4xy. That does give me 37, but it gives me positive. So I'm going to make both of these negative. So that will give us a negative 37. So our answer is across. So we'll have 11 x minus 4y and x minus 3y. These cannot be broken down. They're not perfect square trinomials, and they're not difference of squares, and they're not quadratics that can be doing the box method again. So we're done. Let's move over to number 4. We're going to start with the same procedure for number 4. We're going to take something out, and we are going to check what we can divide all of them by. I can divide this by a 3 and a 7, so I'm going to check with my calculator if 3 or 7 goes in there. And I have decided that 3 goes into all of them, and there's a u in all of them. So I'm going to take a 3u. When I do that, 3 times what gives me the 27? Should be 21 y cubed. So it's going to be 7u squared. 3u times what gives me the 174. And when I divide that on my calculator, I get 58 with the u gives me u squared and v. Then last, 3u times what gives me the 189, and that is plus 63 v to the second power. Now, my question is, does this break down? Let's check it with the box method because it does have that squared there. And so when I do the box method, I'm going to have some binomials, but I can't forget my 3u. So I'm going to do it right now so I don't forget. So 7u squared going there becomes 7u and u. And 63 becomes 7 and 9. 3 and 21 and some other numbers. And let's check. We want to get to 58. 58. So what? 7 times what gives us close to 58? Well, 49 and 63, those do, but I'm going to try the 49 right here. 7, and I need a v. So 7v. And I'm going to put the 9v there, and let's just check. This is going to become 49v, and this is going to become 9v. That does give us 58v. Oh, uv. I should say uv. That gives us 49 uv and 9uv. That does give us the 58, but it needs to be negative. So I'm going to put them negative here so it can both be negative. Then we're going to go across for our answers. So we're going to have 7u minus 9v, u minus 7v, and we have the answer. These, and I know that because the last step in the problem up there says after each step we check. Let's check this. These I can't take any greatest common factors out. They're not differences of squares. We're done. Let's move to number 5 and 6. Number 5, we're going to start off with the greatest common factor. What can I take out of 64x to the 4th and 34x squared y squared and 4y to the 4th? There's not a y in all of them, and there's not an x in all of them, but I can take a 4 out of all of them. When I take a 4 out of 64, or I divide it, I'll have 16x to the 4th. When I divide 4 out of that, I'm going to have 8x squared y squared. And when I divide a 4 out of that, I'll have a y squared. I'm going to do the box method and see what happens. That will give us a polynomial. I'm going to bring down my 4, though. The polynomial is going to actually be 2 binomials. So that's 16x to the 4th. Notice it's a 4th this time. We had just squareds before. 4ths are okay. We can still do those. I'm going to have possibilities of 8 and 2, 4 and 4, and 16 and 1. I'm going to pick 4 and 4 right now. 4x squared and 4x squared. I'm going to do y squared. The only thing that's possibility is y squared. Wait a second. This was y to the 4th right here. Please forgive me. So that makes this y squared and y squared. And that diagonal gives me 4x squared y squared, 4x. Y squared truly does add that up. So it's going to be 4x. Oh, and I notice they're the exact same thing. So I don't need to write that part. I can just write 4x squared plus y squared, and I can do it squared. It was a perfect square trinomial. Number 6. Again, we're going to follow the first step, and it says, look for the greatest common factor. We can take a 5 out of all of them, but in letters, I can't take any letters. They're not the same. There's 2 U's in this one and 2 V's in that, but there's not the same in all of them. So we can take a 5 out. If I divide a 5 out of there, I'll have just u to the 4th. Divide a 5 out of that one, I'll have 10. And divide a 120 by 5, and if you need to do your calculator, that's fine. It's 24. Don't forget your v to the 4th. That, like the one in number 5, we're going to try the box method on this. That will give us some binomials, and I don't want to forget that 5. U to the 4th, what can I plug in for that? Well, that's going to be u to the 4th, u squared over u squared. 24, my possibilities are 2 and 12, 6 and 4, 8 and 3, and we need to make a 10. And this 6 and 4 make a 10 because these don't have any coefficients. So we're going to go 6 and 4, but don't forget we have to split the v up also. But when I diagonal that, that's going to be a positive 10. I need them both to be negative. So we're going to write this. We try to do the across. U squared minus 6v squared and u squared minus 4v squared. At this point, we need to make sure we did this. We checked for them special ones. There wasn't any special, but we could do the box method. Now we're going to check for if there's any more that can be broken down. And I want you to notice that this is a difference of squares. If I would have written that. That's a difference of squares. So I am going to rewrite the 5 and the u squared minus 6v squared. But this yellow section, I'm going to break up because it's a difference of squares, and it can be factored into u minus 2v and u plus 2v. So you need to make sure we're checking that we can break down even after we factored by the box method. That's why they had you factor so many difference of squares so you could start visualizing and seeing them. Let's do number 7 and 8. Number 7, even though we have to the 4th power, this is still a box method. Can I take anything out first, though? Because my trick or my steps is to do the greatest common factor. So can I take anything out? And I can take a 2 out. When I divide a 2 out, I'm left with x to the 4th. Divide a 2 out, I'm left with 8x squared. And then I take a 2 out, I'm left with 16. So the x to the 4th, that makes it really nice. Like really pretty much only one possibility. We could do x cubed and x, but we're going to do x squared and x squared. What about 16? Can I split that? I can split that by 8 and 2, 4 and 4, and 16 and 1. but I need an 8 or a negative 8. So I'm going to have to do negative 4 and negative 4. Ooh, I'm even noticing right now as I'm looking at those. Those are a difference of squares, but let's write them out. X squared minus 4, and I could square that, but since they're difference of squares, I'm going to write them out. This can be split. This yellow one can be split. They can be split into x minus 2 and x plus 2. The orange one can be split also into x minus 2, x plus 2. I want you to notice that these are the same. So I can write this as 2x minus 2 squared. And these two are the same. So we can write them as x plus 2 squared also. So we factored with the box method. Notice we had a difference of squares, but we had 2 of them this time. And they could come together. At this point, number 8, I would like you to pause the video and see if you can do this by yourself. All right, welcome back. There's nothing I can take out of both of these. Nothing I can take out of both of them, so I'm going to just start with the box method. It is in a quadratic-like form. I have a fourth and half over there squared. What can I do with the x to the fourth? I'm going to do x squared and x squared. And 81, I could do 9 and 9. And yes, 9 and 9 make 18, but I'm going to need both of them to be negative. And we have a similar thing that we had last problem. X squared minus 9 and x squared minus 9. So they're both difference of squares. This orange one is going to become x minus 3, x plus 3. And the yellow one is going to become also x minus 3, x plus 3. And these two are the same, and they can be written as a squared. And these two are the same, and they can be written as a squared. So I'll have x minus 3 squared and x plus 3 squared. We have one more, number 9. This is actually really beautiful. We're gonna do this one together. You might notice that this is a difference of squares, but be really, really careful. We are going to have a minus 1 and a plus 1. We're going to have x to the something power. But this is the part that gets some people messed up. The square root of x to the 16th is not x to the 4th. You don't take square roots. You take half of it, because x to the 8th times x to the 8th. We add these exponents to make that. The wonderful thing is this one right here is a difference of squares and can be split. So I'm going to write this one right over here. And we're going to have x squared plus 1. Excuse me. X to the 8th plus 1. It cannot be factored. but the one in yellow can. And it's going to become x to the fourth minus 1. We'll do plus 1. And x to the fourth minus 1. Because when we do the square root, we half that. Because x to the fourth times x to the fourth, we add the exponents to make it x to the 8th. I want you to pause this video right now and see if you can now do something with this difference of squares and see what keeps happening. Come back when you're done. Welcome back. I am going to have you check yourself now. I am going to have you split this one, but I need to rewrite these down below. I will have x squared plus 8 when I rewrite that one, and I rewrite that one, x to the fourth plus 1. But this one gets split into 2. It becomes x squared plus 1 and x squared minus 1. Am I done yet? No, I still have another difference of squares. So I'm going to rewrite all of these. I'll have x squared plus 8, x to the fourth plus 1, x to the squared plus 1, and then this one becomes 2 more. X minus 1, x plus 1. Can I split any more? This negative one is not a perfect square anymore. And I have completely factored that entire thing. You have taken your note sheets and you have followed along with me. I hope you've taken some good notes on them and given yourselves some notes as you were going along. And I hope that you were able to practice some without me and then come check. You have now learned how to factor completely. We are finished.